intersection is 1 comma root 3. Okay, and suppose you rotate this thing around the y-axis. So rotate around the y-axis, and you want to find the area, the volume. Okay, so I'd like you to express the volume in both ways. Okay, use the method of shells and use the method of washers. Okay, just that's it. No? What? The other one is better?
I don't know.
What? Okay, talk to somebody else, please. So, okay, so who would like to tell us how to do it with respect to shells? What's the integral you get? How about Francine? No idea. Really? Xin Xiaojing? No idea. Xu Chenchen?
Using the sum of
Shells, yeah.
volume is integral from 0 to 1 2 pi x times square root 3x dx plus integral from 1 to 2 2 pi x times square root 4 minus x squared dx. And using myself
Washers?
water.
Yeah.
The volume is integral from 0 to square root 3
Mm-hmm.
pi 4 minus y squared minus y squared over 3 1.
Okay. Anybody get something else? Anybody have some other thing? Okay. I think that's right. Right. So right. So method of shells. You've got this thing. You're gonna rotate it around. Right. So you take right? You take the vertical rectangle and you rotate it around, right? So what's the height of the vertical rectangle? Well, between 0 and 1, the height is going to be root 3x, right? So you get the radius is x, so you get 2 pi x, that's the circumference, right? Times the height, well the height is root 3x, right? And then times the thickness, that's dx. Right? And so that's going to give you that will give you the area of this first part here. Okay, the inside part. We also need the area, the volume. We also need the volume of the outside part. Well, that's from 1 to 2. Again, right? If we're cutting at time x, right? Then the radius is x, so we get 2 pi x for the circumference, and then we get the height is 4 minus x squared, the square root of that, and we get dx. Right. So again, circumference times height times thickness. Circumference times height times thickness. Okay. So if you're doing it with shells, you have to break it up into 2 parts because there's two different functions describing the height. Okay. Now for washers, right? Right, for washers, well, you're just cutting like this, right? So you get this thing spun around. Right? You get this washer thing, right? And what's the area of the washer? Well, right, if the height is y, right, then you know this thing is on the circle, so the x is going to be the square root of 4 minus y squared. Right? And over here, we're on this thing, so x is going to be y over root 3. Right? And so, what do we get? We get the integral from 0 to root 3 of pi outer radius squared minus inner radius squared dy. Right. Pi outer radius squared, that gives us the 4 minus y squared, minus inner radius squared, that gives us the y squared over 3. Can you two tell me like where you got stuck? Where do you get stopped? What's the difficult part? What's the difficult part? What can you not do, or what do you find hard? Are you okay with the method of washers? Yeah? Okay. How about you, Anjing? Are you okay with the method of washers? No? Okay. So remember what you need to do, right? You need to find the volume of this pancake with the hole in the middle, right? You have this cake with the hole in the middle. You need to find the volume, right? Well, the volume is going to be pi r squared minus pi little r squared times the thickness, right? Right, with you've got some big radius and you've got some little radius, right? So pi r squared, right? It's going to be, right? The big radius is r, say the little radius is little r, right? The thickness is say dy, right? So the volume of this thing is going to be pi r squared minus pi r squared dy, right? And so you just need to figure out, what are those radii? Just figure out what the radii are. So you say, okay, well, this point here is, right? The x value here is root 4 minus y squared, so that's the radius, right? The radius is root 4 minus y squared. The radius here, right, this point has x value y over root 3, so the radius is y over root 3. Right, so you get pi r squared minus pi r squared, right? Pi r squared minus little r squared. And then for this one, right, the game is that you're trying to find the volume of a cylinder that you get by rotating this thing around. Right? You're trying to find the volume of this cylinder. Well, that's going to be 2 pi r times the height times the thickness. Right? Is that clear? That it's going to be 2 pi r times the height times the thickness? Does that make sense? Right? Because if you unroll it, right? If you unroll it, you get this sheet. Right? If you cut it and then roll it flat, you're going to get a sheet where the length of the top is 2 pi r, the height is h, and then the thickness is dx. Right? You got this dx here. Right? So the volume of that thing is going to be basically 2 pi r times h times dx. Okay. So again, you just need to figure out. So you say, okay, the radius here, the radius is x, so you get 2 pi x. The height here is root 3x, and you multiply by dx, right? And that's between 0 and 1, because between 0 and 1 we have this one function, right? And then from here to here we have a different function, right? We have this function instead. Okay. Yes.
Why the radius is x?
Why the radius is x? Well, what we're doing is we're taking the integral from x equals 0 to 1, right? And so, we're right. So we're basically choosing the radius to be x. We're saying let we're going to let the radius be x as x ranges from 0 to 1, and then from 1 to 2. Okay, so yeah, it's sort of your choice to make it. So it's like, let this. Suppose we cut at x. Suppose we cut at x. In that case, the radius is x. Right? Yeah. So you cut it at x. The height there is going to be root 3x, right? And the thickness is going to be dx. So if you do that, then your radius is x, and your height is this, and your thickness is this. Maybe we should do one more. Do one more. Let's do this one. Okay, so this is one that we did yesterday by the method of washers. And at the time, somebody, I think it was Wonky, asked, could we do it along a different axis? And now we can. Okay, now that we have the method of shells, we can. Okay, so from negative pi over 2 to pi over 2, here we've got y equals 1 up here, and this thing here on the inside is y equals the square root of cosine x. The square root of cosine x. We take this thing, and then we rotate it this way. Right? And we get the cylinder, but the cylinder has something cut out of it, right? Has this funny shape cut out of the middle of it. Okay? And last time we did this by washers, right? Last time we sliced perpendicular to the x-axis, but this time I'd like you to do it by the method of shells. Okay? So take these pieces. Okay? So just take 1 minute and see if you can set it up. I don't want you to take too long on this stuff. turn to somebody nearby and tell them what you got. Okay, what do you get? Anybody like to say? Jiangdongzi, I think you know. What's the answer?
Integral 0 to 1.
Okay.
2 pi y.
2 pi y. Mm-hmm.
Pi power 2
Pi over 2.
minus r cosine
Mm-hmm.
y squared
Y squared.
dy.
Okay. Yeah, so that will, I think that'll do it. Maybe you need twice that,
Oh, yeah.
right? Because you need twice that because what you've gotten is the right half. So you need also another one to get the left half. Okay? But yeah, so let's just ignore the left half for right now because it's the same, it's symmetric. So we can just do the right half and multiply by 2. Okay? And you see what we get is this, we get these guys, right? We get these shells, right? What's the again cutting at height y? So we cut at a particular height y. So then the radius is going to be y, right? The radius is y, and the height of this thing is going to be, well, the difference in x values. Well, that's going to be pi over 2, right? On the right hand side, we've got pi over 2. On the left hand side, the x value is, right, cosine x is going to be y squared, and so x is arc cosine y squared, right? So you get this minus this for the height, right? And you get this thickness, you integrate between 0 and 1, and you multiply by 2. Okay? Okay, you see that this one, you know, it's probably better to stick with the washers. Somebody, I think Wang Di, you asked yesterday, you know, we were doing it with respect to x. Could we have done it with respect to y? And the answer is yes, but it'll be maybe it's more difficult. It is more difficult. Okay. Okay, take a break. Yeah. 2 pi. Okay.
Yeah, 2 pi y.
2 pi y is
So
good.
this part.
Yeah. So I think what you need is the height of this block here, right? Okay. So cosine inverse y squared is actually this length, right? It's actually this length. So if you do this, you're actually getting the area of the volume of this thing down here, and what you're getting is actually the volume of the space inside the cylinder. Okay. Rather, you want to take, you know, look at this thing here is pi over 2, right? You know, this thing here is cosine inverse y squared, and so this length is going to be pi over 2 minus cosine inverse y squared. Okay, right? this from here to here is gonna, from here to here is cosine inverse 1 squared. From here to here is pi over 2 minus cosine inverse 1 squared. It's just like if you had A and B, right? What you were doing was from 0 to A, but what we needed was from B to A.
Oh, okay. But
Yeah.
am I calculating this object or?
What you're getting is the inside object.
Okay.
So you're getting the volume of this sort of lemon-shaped thing on the inside.
Oh, okay.
But what we wanted was the cylinder minus the lemon and what's left.